So electrical circuits topic.
4.2. We did the first MCQs related to this topic. We'll do more from this. The first one, section 11. A metal conductor is connected to a battery. Which statement describe the current in a metal conductor? So we have two flows. One is the conventional current, which we say it's from positive to the negative, and the other one is the electron flow, that is from negative to positive. So it cannot be C or D because it's not the flow of the proton. So we are left with A or B. So it is a flow of electron, and how the electrons will move. Electrons will move from negative terminal of the battery to the positive terminal. In question 12, in electric circuit, a 40 coulomb of an electric charge passes through a point in 5 seconds. How to find the current? So we have the formula that the current is charge divided by time. So how much charge flows through? That's 40. And how much time it takes? That's 5 seconds. So 40 divided by 5, that's equal to 8. And the unit of the current is ampere. So 8 ampere, C will be the right answer. For electricity, the most important thing for the electricity or circuit question is the formula. Like you have to learn the formulas, the formula for the current, voltage, electric power, energy, and resistors connected in series and in parallel. Which circuit should be used if we want to find the resistance? If we want to find the resistance, we need a voltage and we need a current. And to get the voltage, to find the voltage, we need a voltmeter. And to measure the current, we need an ammeter. How the voltmeters are connected? Voltmeters are connected in parallel or up or down. And how ammeters are connected in series before or after. So when we check here, we want to find the resistance of this fixed resistor. The ammeter position is correct, but the voltmeter is not correct. Here, voltmeter position is correct, ammeter position is not correct. Here, voltmeter is in series, so that's wrong, and ammeter is in parallel, so both of them are wrong. For the ammeter is in series before or after, and voltmeter is in parallel, means above or below, or up or down. So that's why D is the right answer. Is it clear? This one?
Yes, clear.
Okay. In question 14, which electrical quantity is defined in terms of energy supplied in driving charge around a complete circuit? So we have EM, because anything which is current is related to flow of the charges. Like how many charges will move through a circuit every second, that is referred to electric current. Power is how much energy is used in a certain time interval. So it's joules per second. This is joules per coulomb, this is also joules per coulomb. Electromotive force EMF, which is also volts, and potential difference is also volts, the unit. So which electrical quantity is defined in terms of energy supplied in driving the charge around? So how much energy is supplied to move the charge around the circuit? So if we have a 10 volt supply, so if we have a 1 coulomb of a charge, how much energy will be supplied to this charge? 10 joules of energy supplied to the charge so that it can move around the circuit. So energy given to the charge or supplied to a charge to move the charge around the circuit, what we call that as EMF or electromotive force. But when this charge is moving through a circuit, it consumes its energy. Like example, if it was having 10 joules, one of coulomb was having 10, it uses 3 joules, like it is left with 3. So how much it used here? It used 7. And remaining it used across this one, so this will be 3. So potential difference is how much energy is transferred by the charge, where electromotive force or EMF is energy supplied to the charge. That's why D is the right answer. In question 15, a student set up a circuit containing a battery, two cells and three lamps are shown. With diagram, so first we have cells, so if we try to draw the same, copy the, make a circuit symbol, so we have a cell, negative, positive, then next to that another cell is connected, then we have a lamp, with this lamp another lamp is connected, and with this lamp is another lamp in parallel, and then the circuit is going back, like the wire connection going back to the negative terminal. So means two lamps in parallel and one of them in series. So two lamps in parallel and one of them in series, so it matches with A. Is it clear? So these two lamps are in parallel and next to that a series lamp is there. So this is the same circuit as this one. Any doubt in this?
No.
Yes.
Clear? A cell has an EMF or electromotive force of 1.5. So what does it mean? It means it will use 1.5 joules of energy to move one coulomb of a charge. So what does this statement mean? It means the cell convert or use 1.5 joules of energy when it is moving one coulomb of a charge around a complete circuit. So the definition of EMF is actually it is energy or a work done on a unit charge or one coulomb of a charge. Like how much energy we consume or how much energy is supplied by the cell or a battery to move one coulomb of a charge around the complete circuit. You have to learn the definition of EMF. The circuit containing a cell of electromotive force of 2 volts, 3 resistors, 3 ammeters and 2 voltmeters. 1 ammeter is labeled P and 1 voltmeter is labeled Q. The reading on the other 2 ammeters and one of the voltmeter is shown. What is the reading on P? So how we can work out? See, if this is 0.5, so how much voltage will be here? 0.5. The total voltage is 2. So out of 2, if 0.5 volt is across this component, how much is the remaining voltage? So the remaining voltage is 1.5. So 1.5 across, and because they are connected in parallel, so they will all have the same 1.5 because in parallel the voltage is same. So each of them will have the voltage of 1.5. But what about the current? A 2 ampere of the current flow through this one. Then out of 2, if 0.5 is moving from here, so how much current will flow from this one, the remaining, which is 1.5. So 1.5 will be the current here and 1.5 is the reading on the voltmeter. That's why A will be the right answer. Is it clear, Iswan?
Yes.
In question 18, in a circuit, in which circuit is an ammeter measuring the flow of the charges through a lamp? So whenever we want to connect an ammeter, ammeter is always connected in series, means you can connect the before the component or you can connect the after the component. And we want to measure across the lamp. So this is totally wrong because ammeter is connected parallel, like above or below, it should be before or after. So B is connected in series with the lamp, so it's right. What about C? C is totally wrong because it's parallel across the component. And D also is wrong because it is parallel across the component. Ammeters should always be connected in series before or after. In question 90, the diagram shows a piece of a metal resistance. Which wire made the same metal has small resistance. This resistance depends on the length. Longer the wire, higher the resistance. Shorter the wire, lower the resistance, less resistance. And it's inversely proportional to cross-sectional area. Large cross-sectional area, smaller resistance. Smaller cross-sectional area, high resistance. So if you use the same length, because if you use a greater length, so resistance will increase. So C and D cannot be an answer. If you use the same length and we increase the area, so a large cross-sectional area, as a result, it will have a low resistance. So if we want to reduce the resistance of this wire, what we should do, we should use a large area and a smaller, the same length if we are using, so we should use a large cross-sectional area which reduce the resistance. Which two changes to a metal wire both decreases the resistance. So resistance is directly proportional to length and it's inversely proportional to area. So if you want to reduce the resistance, we should shorter the length, and if you want to reduce the resistance, we should increase the area. So decrease the length and increase the cross-sectional area. That's why B will be the right answer. So these are some questions from the electrical circuits, topic 4.2, electrical quantities. Any question or a doubt you have related to the session today?
No, sir.